Okay, so here we're going to have some video notes about matrix operations, things that you can do with matrices. So to get started, I want to make sure we can all label these correctly. So the way that you label a matrix is you count how many rows down there are and then how many rows over there are. So if you take a look at this very first one, just this one right here, if we take a look at that one, just that. Okay, so that's got, if we count it, that's got 1, 2, 3, 4 numbers on the way down and just one going across. So that's considered a 4 by 1 matrix. So that these both are 4 by 1. Now I'm not going to leave that there, but those are called 4 by 1 matrices. Okay, so I think I will go ahead and write it right up under here. So you can put that here. These are 4 by 1. Okay, adding matrix are very easy. You just add the specific spots. So I'm going to go ahead and add that spot and that spot. So I'm going to have a 4 by 1 matrix, gives us back a 4 by 1 matrix, and we just take the 3 plus the -2. So the 3 plus the -2 is going to give us a -5 in that spot. And then, of course, the next one is going to be the 1 plus the -1. So that's going to give us a 0 in that spot. And then the -1 and the 2 will give us a 1 in the third spot. And the 6 plus the 6 will give us a 12 in the fourth spot. So this first matrix plus this second matrix gives us this third matrix, which is still 4 down and 1 across. Okay, if we come over and take a look at the other one, so now this one is subtraction, and we've got a very similar thing now. So now just labeling it, if we take a look at the label, how many down is 1, and how many across is 3. So these are considered 1 by 3 matrix, which means we're going to get back a 1 by 3 matrix. And then we're just going to do subtraction of the spots. So the first spot is a -3 minus a 5. So -3 minus 5 makes the first location a -8. And of course the next one is a 4 minus the 3. So 4 minus 3 puts a 1 in that spot. And then we have a 3 minus -3. 3 minus -3 is +6. So we end up with a 1 by 3 matrix there. Okay, when we take a look at number 3, it's got, when we take a look at how many values there are, there's 3 going down. So we have a 3 by, and then there's 2 going across. So there's a 3 by 2. That means we're going to get back a 3 by 2 matrix. Okay, so addition and subtraction, we just do corresponding locations. So this is in the upper left corner. We're going to subtract the other upper left corner. So 2u subtract 1. So the upper left corner of the answer is just 2u subtract 1. Let me make this a little bit bigger. Okay, so then the next one will be maybe the upper right corner minus the other upper right corner. Okay, so we have 0 minus 5. Is this going to make that upper right corner of the answer? 0 minus 5 is -5. Okay, now I'll take that position and that position. So I've got -2v subtract -v, so it'll make it +v, subtract -4, so it'll make it +4. So that negative has to get distributed in there. So -2v plus v ends up being a -v, and then we have this +4. Okay, middle right minus middle right. So I've got 2v squared minus -2v. So 2v squared minus negative makes it plus 2v. Okay. Take the VU and subtract a minus and subtract a negative 5. So if those are not like terms, so we have VU, subtract negative, so that'll be plus 5U. And then the last one will be that position minus that position. So we've got V squared. Now it's going to be, that negative has to get distributed in there, so it's going to be minus 5 minus U. So that's the last spot. V squared minus 5 minus U. And there's our 3 by 2 matrix that we have left. So it's real simple. You just have to add and subtract the spots as they come. Okay, so here, if we take a look at this next one, how many down? So that's a 4 by 2 across, and this one is a 2 down by 4 across. Now, what will we get out of that? At the first one, we had a 4 by 1 plus a 4 by 1 gave us a 4 by 1. Here we have a 1 by 3, a 1 by 3, we got a 1 by 3. Here we have a 2 by 3, we subtracted a 2 by 3, and we got, we have a 3 by 2, a 3 by 2, and we got a 3 by 2. Okay, so what happens if they're different? So we're going to try to add the spots. So if I were going to try to add the spots, I need the upper left plus the upper left. Okay, there's those two. Then I would maybe come over to the upper right. So now I'm not sure which one to do. Is it this one or is it that one? But either way, there's not going to be a third one to go, so they don't match up. The spots don't match up. I don't have enough across. I only have 2 across, and then I have 4 across. If the spots don't match up like that, then this is an undefined matrix. You can't do this one. So we call this one undefined. So we can't add those together unless, you cannot add matrices together unless they're exactly the same size. Okay, next one is called scalar multiplication. All it means is we're going to take some number and multiply it in there. Okay, so scalar multiplication is as simple as it sounds. I'm just going to take, it's almost like the distributive property. The negative 4 just gets multiplied in there. So we end up with a 1 matrix down and 4 across. So I have negative 4 times negative 4 will be positive 16. Negative 4 times negative 6 is positive 24. Negative 4 times 3 will be negative 12. And negative 4 times negative 3 will be positive 12. And we ended up with a 1 by 4 matrix. That's all. That's called scalar multiplication. So number 6 is exactly the same thing. We have negative 2 times negative 4. That'll give us an 8. Negative 2 times 2 will be a negative 4. And then negative 2 times negative 1 will be a 2. And it's that simple. So addition and multiplication, you just add the spots and you multiply the spots. Now it doesn't matter how many you have. So here these are all, when I take a quick glance at it, these are all 4 by 1s. 4 down, 1 across. 4 down, 1 across. 4 down, 1 across. So I should be able to add and subtract all of these, and I'll get a 4 down, 1 across. So I already know what the answer is going to look like. It's going to look like 4 down and 1 across. Okay, so I need to take negative 6, subtract 6x, subtract negative 6y. So the top spot, none of those are like terms, so the top spot is just going to be negative 6 minus 6x minus minus, so plus 6y. Okay, the second spot is going to be 4x minus that. Now I just need to make sure I get the negative on both of those, and then minus 0. So I have 4x minus minus 6, so plus 6 minus y. Now notice these are all just one location. They're just a long number, but this is just the top single spot. This is the second single spot. Okay, and then the third spot. Similarly, I need this piece minus xy minus this piece. Okay, it looks like we might have some like terms here now, so I'm going to put this on the side. So I've got 3x squared minus 1, but then I've got to get this negative into there, so it's going to be minus xy, and then this negative goes on both of them, so it's going to be minus x squared plus 2. Now 3x squared and minus x squared are like terms, so when I put that one in there, 3x squared minus x squared is 2x squared, and then I've got a negative xy term, and then here I have a minus 1 and a plus 2, so that it'll finish off with a plus 1. Okay, then the last spot is going to be 0 minus minus y minus y. So I've got 0 plus y from the second one, and then minus y. Well, the y's go away, leaving the last spot just to be 0. So it doesn't matter how many there are. There can be a string of them. As long as they're all the same size, you can add them together. So here we have number 8. This one's a 4 by 2. So it's 4 down and 2 across. But this one is a 4 by 1. It's already not going to work. I'm not going to be able to add a 4 by 2 and a 4 by 1, so this one is undefined. I'm just going to abbreviate undefined like that. Okay, looking at number 9, this one is a 4 by 2. This one is 4 down by 2 across, and this one is 4 down by 2 across. I should be able to add these together. So I'm going to end up with a 4 by 2. Okay, first spot. That plus that plus that. Okay, none of those are like terms, so we just have a v minus 2w plus 0 minus 5vw. So none of those are like terms, so we're good there. Okay, maybe the next one across. I'll put these in boxes. 3v plus w plus 1 minus 5w. Okay, the w's are going to have like terms. So I've got a 3v, and I've got a minus 5w and a plus w. So that's going to be negative 4w. And then we have just plus 1. Okay, the next one down, we've got a 6uw and 4w. Okay, those are not like terms, so I've got a 6 plus a 6uw plus 4w. And then the other spot is going to be a 0 plus a 6w plus a v. So just 6w plus v. Okay, the next one down, we got that one plus that one plus that one. So like term-wise, we just have 3uv. I've got a minus, I guess I just have a single v from right here. Okay, I've got a minus 4u, and then as far as values are concerned, we've got a 1 right here and a minus 6 right there. So 1 minus 6 will be a negative 5. And then in the box, w plus 3 minus 5v, and then w minus 4. So I've got 2 w's. Two w's. got a negative 5v right there. And then a grand total of -1. And then the last row, we've got a 5u, a 3w, and a -2u. So 5u and -2u is 3u and a 3w. And then a v plus 5, a wv, and a v squared. None of those are like terms. So we just have, I'll put it in order. So I'll go v squared plus wv plus v plus 5. The order there doesn't really matter. Okay, and so number 10 should be a real simple one now. I've got a 4 down by 1 for all of them, so that should end up with a 4 by 1. So taking the top row, -5 plus 5 minus 3, 1 plus 3 minus 2, so 1 plus 3 is 4 minus 2, 0 plus -4 minus 5 will be -9, and -1 plus -4 minus 3, -1, -5 minus 3, -8. Okay, that's how you add and multiply matrices. On the other side, it's add, and it's called scalar multiplication. What we did up here, this is called scalar multiplication. It's not just multiplication, it's called scalar. This number is called a scalar, a multiplier. Okay, let's stop there. I'm going to do the next video for the next side.